Hi, welcome back. Today I want to talk about digital accessibility for virtual reality experiences. Digital accessibility is the accessibility of a computer system for all users regardless of disability type or severity of impairment. Now, estimates vary, but it's estimated that anywhere from 15 to 20% of the global population has some sort of disability. So what this means for you as a VR experience developer is that 15 to 20% of your users may have a bad experience unless you keep certain things in mind when you're designing your VR content. And some of those things include accessible navigation, accessible motion, and captioning. Today I want to give some examples of those things. Let's start with accessible navigation. Now, there are three main types of navigation in virtual reality at this point, and those three types are gaze, controller, and hand. Now, gaze is when you control the experience just by turning your head or looking in a certain direction. Controller is, of course, for whatever headset you're using, the native controller that's attached to that. And hand is a newer feature on a lot of headsets, and that's where the headset itself actually tracks the motion or the position of your hands, and you utilize your actual hands and the virtual representation of them to interact with the experience. So when you're creating virtual reality experiences, it's important to ensure that you afford users multiple types of options for this interaction and this navigation. If, for example, you were to create an experience where only controller use was allowed, you would be making it so that those users who are limited in some way from utilizing the controller, for example, paralysis or limited motion, you would be making it so that they wouldn't be able to interact with your experience. Additionally, if they're using, for example, a mobile device rather than a headset, they wouldn't have controllers, and so you would be leaving out that potential customer base as well as leaving them out from the enjoyment of your experience. So, noting that, it's important to create experiences with that in mind. If you're able to, ensure that you have an option to have gaze-based interaction rather than just controller-based interaction. And then additionally, if you have hand tracking, for example, you want to also allow for controllers and gaze-based interactions. The next thing you want to keep in mind to ensure that your virtual reality experiences are accessible is accessible motion. So cyber sickness is very well known among virtual reality content creators and the virtual reality community, and this can be caused by all sorts of things: jarring movement within the headset, changes in auditory levels on one side of the headset versus the other, and then additionally issues with native headset frame rate versus the experience frame rate can cause all sorts of jarring effects that can cause nausea or other symptoms of cyber sickness, virtual reality cyber sickness, when those things happen. So one thing that can be done to ensure that this is less likely to occur is to do your best as a team to make sure that your frame rate is appropriate for whatever headsets it's on. You can utilize analytic data to figure out what type of frame rates are the experiences are resolving to when users are using them on various headsets. Take, for example, the Oculus Quest headset. The Oculus Quest headset has a 72 frames per second frame rate, and so that means that in order to be optimal, your experience should be drawing a new frame every roughly 13.8 milliseconds. And so it's important to optimize your code and to compress things when you can, especially in the context of web VR or any web XR experience, since due to the nature of the technologies being used at this current stage in web VR and web XR development, frame rate can be an issue for sure. New improvements are constantly made to allow for better GPU usage within the browser and, you know, utilizing JavaScript and 3JS and things like that. So, you know, optimization of frame rate for, you know, the device you're planning to release on, or for across multiple devices, is really important to ensure that you know, cyber motion sickness is less likely to occur. So that's accessible motion. And the next one is captioning. You would be leaving out all users that are hearing impaired if you don't allow for captioning of experiences where audio would otherwise be the only means of communicating information. And, you know, there are other scenarios like low vision, things like that, where captioning can become very important. For example, captioning so that a screen reader on a desktop or mobile device is able to read out the content that is meant to be displayed, you know, visually, even at the subtitle level. So those users who are low vision or without vision won't be able to really interact with your experience unless you have captioning. Now, regarding the specific ways to implement things like these, it's an evolving standard and as we know, it's a very nascent industry, the virtual reality industry, and even more so the web virtual reality industry. And, you know, there are all sorts of people doing their best to ensure that we have appropriate standards, and that you know, that there are principles that can be adhered to make this a easier process for developers, so that the effort involved in making experiences accessible doesn't dissuade content developers from doing so. So I wanted to talk about two proposed ways of making your experiences accessible. One of them is a list of guidelines. They're referred to as virtual reality checks that were proposed by the Oculus team. And that's a list of 9 recommendations called virtual reality checks given by the team that are proposed to make your content more accessible. And that list includes: 1, the app should be playable without audio. 2, text and in-app controls and elements necessary for app progression should be clearly legible. 3, the app should provide clarity and direction to the user through a combination of visual, audio, and or haptic feedback when possible. 4, the app should provide an option to be played with one hand and or controller. 5, the app should enable people to edit their display settings such as brightness and contrast to accommodate for their visual needs. 6, the app should either provide color blindness options or use other techniques such as combining color and pattern for easy visual distinction. 7, the app should provide the user with the option to rotate their view without physically moving their head or neck, which is very important for accessible navigation. 8, the app should support multiple locomotion styles when possible, for example, allowing users to have a seated option versus standing option. This is very important for users who use wheelchairs. It is also very important just as a usability standard, so because not everyone wants to stand up during a virtual reality experience. And then 9, of course, that applications that can be used in sitting or standing mode should provide a setting to enable users to perform all interactions and access information from a fixed position. So those are 9 virtual reality checks proposed by Oculus, and at this point they're recommendations and not actual requirements. I'm really glad that they proposed these, as it is a statement that they support accessibility and they want to ensure that there's inclusion for all users of virtual reality. And so I hope that this list evolves, and I hope that people take it to heart and work toward ensuring that their content is accessible. You know, another list proposed, not quite recommendations, but more just proposed principles of design, I want to go over as well. And that's a list proposed by Doug Northcook. He's a professor of Chatham University in Pittsburgh, and he posits that 7 main accessible design principles should be followed when creating VR experiences to ensure that they're accessible. those 7 design principles are equity in design, flexibility, simple and intuitive design, perceptible information, tolerance for error, physical effort, and size and space. So, let's go through that list. Equity in design, that's just pointing out that when you're doing your user testing, especially user acceptance testing, you want to ensure that you bring in a lot of different users from different backgrounds and with different characteristics to get a better picture of how your experiences are received by a broad audience. Flexibility is ensuring that when possible, the experience can be interacted with in a variety of ways. For example, consider how many ways a user can reach out and grab an object. Might you want to allow for them to have a gaze-based option to grab an object rather than just being able to reach out and, physically make the grasp motion with their hand or with their controller? Additionally, might you want to include an option to magnetize item toward themselves? These are all design questions that have to, at the end of the day, be decided on by the developer. But these are questions to consider when trying to decide whether or not your experience is accessible for your users. Simple and intuitive is the next one, and this design principle is just that experiences should be usable by people who are using VR for the first time and users who are not very well acquainted with VR. Those who are new to VR don't have the same intuitions as someone who's a well-versed VR user or a gamer. So you want to ensure that the navigation and the engagement and experiences is as intuitive for them as it is for the users who are well acquainted with the system. Simple means seamless, and for example, you may want to consider that most actions are done with minimal button pressing and things like that. This will ensure that users have a good time, and that the content is what matters rather than the learning curve of that content. The next one is perceptible information, and that's just pointing out that you want to ensure that you rely on multiple senses to impart information. Users should have really good feedback for any sort of dialogue. That means adding subtitling, audio feedback, haptic feedback, even taking things into account like color blindness, hearing impairment, and restricted field of view are really important in your design. You want to note too that device differences can also be important when considering whether or not the information is perceptible. Take, for example, Oculus Quest 2 versus Generation 1 Oculus Rift. Something that might appear clear in Oculus Quest 2 may not appear as clear in Oculus Rift Generation 1, just because the technology was different at the time. The next one is tolerance for error. Users don't always do exactly what you might have expected them to do. So what you want to do is design your experiences so that when a user engages in a behavior that might create a high probability of cyber motion sickness, a high possibility of landing in an area that wasn't really intended to be landed in, then there are safety checks for that. So you really just want to ensure that you consider edge cases of human behavior within VR so that users don't experience some sort of virtual or in fact physical jarring as a result of user error. So that's another big thing. The next is physical effort, and that's what was brought up earlier regarding virtual reality checks. You want to ensure that users can have a seated experience as well as a standing experience. You very well may want to allow for lying down even. So that stuff's important. You don't want to, if your goal is to create an accessible experience, then you want to ensure that it doesn't necessarily rely on room scale VR, that a user could do it from a fixed position and things like that. The next is size and space. For example, can you accommodate users that just have 3 degrees of freedom? For example, those users who are using the Oculus Go. or does it require 6 degrees of freedom? Or for example, are users of all heights able to appropriately engage with your experience? This is stuff that you'll want to consider when creating your experiences. And if you can, try to accommodate as many people as you can. To wrap up, virtual reality and augmented reality, it's a nascent industry, of course. Adoption is not massive at this point. There's a lot of adoption, but it's not massive at this point. And that's even more so the case for web XR technologies. So that's virtual reality and augmented reality in the browser. It's a nascent industry. And therefore, accessibility and, the nuances of these technologies have not necessarily been fully hashed out at this point. And they are evolving standards, and there are teams of researchers, and there are great developers and teams of developers that are working to ensure that there are guidelines and trying to find out ways to ensure that experiences are more accessible. And, as this is done, it's going to be great because the added inclusivity is going to increase the adoption of the technology. And additionally, it's just going to make it so that, the virtual reality experiences are that much better. Affording a good experience for all users goes miles, and that's not just for differently abled users, that's really for all users. Anytime you can make the experience better, more inclusive, more varied, and more configurable, people are going to have a better time because they're going to be able to do things on their terms and enjoy the experience that much more as a result. If you like this content, please give me a thumbs up. If you haven't already subscribed and you want to, please subscribe. Comment down below if you have any questions or you want to add to the conversation. And I'll see you guys next time.